Now we're going to be working on adding and subtracting fractions. We start out with fractions with the same denominator. This is 7.3. Adding, subtracting. Polynomial fractions. And in parentheses here, they already have the same denominator. I'll put a little asterisk there because they could be off by a negative sign. So you won't have to multiply. Oh, nice, I made it. That's a first. Okay. So they could be off by a negative sign. That'll be the only difference they might have, and you'll have to deal with that. However, if they already have the same denominator, then you have a pretty straightforward set of general steps. Okay, 1. Make sure they have the same denominator. If not, multiply the top and bottom by the same thing to give them a common denominator. Again, in this section I already said they have the same common denominator, but the one thing that might show up is just a hint to remember. Okay, when you see something like 4 minus x, which has shown up a lot and will continue to show up, you need to remember that 4 minus x is the same thing as negative x plus 4 or negative 1 times x minus 4. Okay, and that's that whole a minus b equals negative b minus a. Okay, so just remember that one exception, because sometimes, even though the denominators are very similar, they might be off by that negative sign. This would be what it looks like. 4 minus x, x minus 4. Okay, so if they're not the same, multiply them. We'll deal with that when it comes. Okay, 2. I'm going to do it over here, so we got a lot more room. Add, subtract. Oops, let's just say. Okay, add, subtract the fractions like normal. In other words, add the numerators together. Keep the common denominator the same. Just like if I had 3/4 plus 7/4, that would be 3 plus 7 all over the common denominator, or 10 over 4. And then the third step's the most important, maybe. Factor and simplify. AKA what we've been doing so far, so section 7.1. So all the problems to start out will absolutely just match up exactly with denominators. Okay, so you'll just add the tops. Quick examples. 2. 3x over 17 plus 8x over 17. How would we add those? That's it. Right? This would be, I'll do it down here. 3x plus 8x over that common denominator, or 11x over 17. That's when we would factor and simplify, but there's no factoring to be done, and they're both prime numbers, so there's no simplifying to be done. Okay. Another one, teeny bit harder, same idea. Okay, so already over a common denominator. So Sarah, what would we do?
Add them so we get 15 over 9x.
Exactly. So we get 15 over 9x.
Divide by 3.
And then we're not done, because that last step we always need to check if we can reduce. So we divide by 3 and we get 5 over 3x. And then we're done. And then of course they might do it with polynomials, right? So 16 would be something like 3x plus 2 over 3x plus 4 plus 3x plus 6 over 3x plus 4. Alright. So Jacob, what would we do? Yeah, which parts would we add?
The top.
Yeah, it's just the tops, right? So you just write it out like this, 3x plus 2 plus 3x plus 6 all over 1 over that same denominator, so what do we get on top?
6x.
Wait, Jacob's got it, plus?
Oh, 8.
Yeah, plus 8 all over,
Yeah, plus 4.
perfect. And then what would we do? Shh,
Simplify.
simplify, but how?
I was talking about something.
Yeah, so we're gonna factor, right? That's the big simplification, is we factor everything on top, we factor everything on bottom. So, what's the one thing we could factor, anybody? The GCF of
6x plus
of that top thing is?
2.
Exactly, so we take out a 2 from the top, and so it's 2, 3x plus 4 over 3x plus 4, and now that everything is factored, what can we cancel?
3x
The entire 3x plus 4. Yeah, so it's 2 over 1, or just 2. Okay. But the big thing is, you can never at the beginning say, oh, look at 3x and a 3x. Right? You can never say, oh, look at 3 and a 6, or a 2 and a 4, or an x and an x, right? There's never any way you could take one part of a group with one part of another. And I'm going to repeat that over and over this entire chapter, because never will you make that mistake.
You say that again.
What was that?
You say that again.
Yeah, I will. Just worry. I will say it over and over and over. Every section I introduce, and I'll say, and you can never. People will still do it. Mistakes happen. Okay, one big thing to remember. I already brought up that negatives are going to be an issue we need to deal with, but let me bring up one other way in which they're important. Okay. Or I'll just write it out. When you take away a fraction or you subtract a fraction, you're subtracting everything from the numerator, so you have to distribute the negative, okay? And this is going to be a really common mistake. So we get something like 2y plus 1, 3y minus 7. And you're seeing a theme here, right? These mistakes that we pointed out in chapter 1 are still haunting a lot of people now, and we're in chapter 7. And we're only going to chapter 9 in this class, So you're seeing the same mistakes, distributing the negative. That I told you, I think literally the first day of class, when we did order of operations, I told you that mistake is gonna amount to, maybe, some like fifth or something of all the mistakes I deal with. Okay, maybe that's too many, but still, it's big. When I write this out, I'm saying I've got, the tops are added. I got 2y plus 1, and I'm subtracting y plus 8 all over 3y minus 7. But I'm not writing it like this, because this would say just subtract the 8. And I'm not just subtracting the 8, I'm subtracting this entire group. So I should have parentheses here, because that's what this division bar means. Everything below is a group, everything above is a group. So when I subtract this entire fraction, I need to distribute this negative to the y, distribute it to the 8, and if there were more terms on top, I distribute that negative to every single term, because I'm taking away that entire numerator. Alright? So, when I rewrite it, after distributing the negative, I'm taking away the y and I'm taking away the 8. This is the one that people forget. Okay, that minus 8. And then it's just like any other problem, right? It's just, you gotta remember when you're subtracting it, you're subtracting the entire group. So, 2y minus y is y. 1 minus 8 is minus 7 over 3y minus 7. Oh, could I cancel the y minus 7s?
Sure.
No.
Sure you cannot?
Yeah, no, because,
Very good.
yeah,
That's great.
exactly. It's a 3y minus 7 and a y minus 7, which are nothing alike. But that's not true. I mean, they're somewhat alike, but they're not exactly the same. Alright, a couple more examples of that. Really, it's just negatives that are going to give people trouble in this section. Otherwise, you are just adding the tops together, and after you get one fraction, you simplify by like 7.1. The only trouble here is make sure to be careful with your negatives. Okay, here's another example, 32. X to the third minus 3 over 2x to the fourth minus 7x to the third minus 3 over 2x to the fourth. Okay? What would I do first?
It'll be x cubed minus 3
Yeah?
minus 7x cubed plus 3
Exactly.
over 2x.
Exactly, because I distribute this negative into this entire group. So I'm subtracting both of them. And subtracting negative 3 becomes positive 3. The reason again is because I'm subtracting this entire group, not just the 7x to the third. Okay, yeah, so x to the third minus that's negative 6x to the third minus 3 plus 3 all over 2x to the fourth. And then, Frankie, we going, what can I simplify?
Oh, that's 6 and 2.
6 and 2, this becomes negative 3 and 1.
It'll be negative 3x cubed over x4, 1x4.
Can I simplify some of those?
Can we?
There's x's and x's. It's one term and one term, it looks like.
Oh, yeah, so it'll be negative 3 over x.
Exactly. 3 of the x's, cancel with 3 of the x's. On top I'm left with 1, on bottom just x. So negative 3 over x. Okay. One more example with distributing negative. This one, now with just more terms. Okay, here's 36. 2y squared plus 6y plus 8 all over y squared minus 16 minus all over y squared minus 16 y squared minus 3y minus 12. Okay. Victoria, what do I do first?
You subtract the top, or yeah,
What do you mean?
subtract the top.
Yeah? I mean, what am I writing here, yes?
2 over y squared minus 16
Yeah,
minus y squared plus 3y plus 12.
exactly, because I did what?
Distributed the negative.
Because I distributed that negative, I'm taking away that entire group, so I distribute that negative in. Yeah, and then it's just canceling. 2y squared minus y squared, 6y plus 3y, 8 plus 12, all over y squared minus 16. And are we done? No, of course not, right? The top, we factor like this, we get, it's 3 terms, there's no GCF. So adds to 9, multiplies that, that's 4 and 5. So I got y plus, oops, that's a crazy y plus 4 times y plus 5, all over, and what's the bottom factor of 2 squared?
Y squared minus 6.
So it is y squared by 16, but how can we factor that? It's a really common one.
Y plus 4, y minus 4.
Exactly, getting really comfortable with that difference of squares because it shows up so much. And then what can we do?
Cancel.
Exactly. So our answer is y plus 5 over y minus 4. Okay, one last note, which is that very first asterisk I put, which is the very first hint I gave, is what if the bottom is off by a negative sign, okay? So remember, 2 things. 1, that 7 minus x is equal to negative 7 plus x, negative 1 times x minus 7. Okay? And 2, when I have 5, 6 plus 2/3, how do I make them over a common denominator?
Say that again.
How would I make these over a common denominator to add together?
Figure out what goes, well, 6 and 3, I mean,
Yeah.
3 goes into 6, so we times 2/3 by, times 2 on both.
On both top and bottom, okay?
So it'll be 5, 6 plus 4, 6,
Exactly.
which comes out to 9, 6, comes out to.
Where are you? We just want to know the method.
Oh, okay.
Right,
I
so
thought
to
you
make
wanted
a common denominator, we multiply the top and bottom by the same number. Okay, so remembering these 2 things, we can now solve a problem with this in it. Okay, so let's do one. And it's the last type of problem we're going to look at today. So here's problem 40. 6 over x minus 5 plus 2 over 5 minus x. Okay, so they don't look like they have the same denominator, yet the title of the section clearly says they do have the same denominator. So,
We would change the 5
Yeah.
minus x would be
Negative.
negative x plus 5,
yeah, which would have a GCF of -1, so how could we rewrite that then?
would be negative 1,
So let me write this first, yeah, and so this would be,
2 over negative, I can't say it, negative 1 times x plus 5, oh, x minus 5.
there we go. Okay, so first we can factor out that -1. That's totally stock, normal stuff we've done in the past. Here's the new part. How would we make those over the same denominator, remembering that second factor over there?
Do we multiply by 2?
Not by 2, but we are going to multiply by something. Right, what number could we multiply top and bottom by to now make these be the same denominator?
-1.
Ah, if we multiply the top and bottom by -1, what's -1 times -1? Or just 1, yeah, so now this is equal to 6 over x minus 5 plus -2 over x minus 5. Okay? So by multiplying top and bottom by -1, we now have the same denominator. And the last, many problems from 40 to about 60 or 70 are all gonna be using this idea. If you have that thing reversed over here, it's off by a negative, you could factor that negative out and see, look, they are the exact same other than that negative sign, so multiply top and bottom by -1. Now they're the same, add them together, just like all the other problems. So we get 6 plus -2 over x minus 5, or 4 over x minus, whoa, why did I box just x minus 5? There we go. Okay, so just doing another example like that, same thing. Okay, here's 44. Here's 9x minus 1 over 7x minus 3 plus 6x minus 2 over 3 minus 7x. Okay, right away you notice the number shouldn't come before the x in that second one. And you just notice the denominators aren't the same. So I go, wait a second, so this is -7x plus 3. Wait, that's a GCF of -1. So that's -1 times 7x minus 3. So right away I just rewrite this as 9x minus 1 over 7x minus 3 plus 6x minus 2 over this. Okay, so everybody should be able to get to there because we've been doing that over and over with this factoring. Anytime the lead coefficient is a negative, we pull that out. So what will we do now?
Times -1,
Yeah,
both sides, I mean, both sides.
okay, and
Get -6x plus 2,
exactly, because you have to remember
distribute that negative.
to distribute the negative. Oh man, layers on top of layers now, right? When you multiply that in, you have to distribute it, because that top is a group. So 9x minus 1 plus, and here's -6x plus 2, and they're over the same denominator. So now you can add them together, you get 3x plus 1 over 7x minus 3. Okay? And that was the last type of problem I wanted to show you two of, okay? Other than that, all of them have the same denominator. Just be really careful, anytime you're subtracting, the negative goes in, and anytime they're off by a negative, you might have to multiply top and bottom by a negative, so they have the same denominator. But other than those negative signs, same denominators at the tops. Alright, you guys got about 20 minutes to work on this. Up again, ask questions, I'm around.